Okay, example 4 on 6.5. Find the exact value of sine of inverse sine of 3/5 plus inverse cosine of negative 5/13. And again, let me just restate this to make sure there's no confusion. Anytime you see an inverse trig function, they're representing it as an angle. So inverse sine of 3/5 is an angle in a triangle, and inverse cosine of negative 5/13 is an angle inside a triangle. And we want to put these things in the correct quadrant based on the range of these inverse trig functions. Inverse sine lives in either the quadrant 1 or quadrant 4. 1 positive, 4 negative, 3/5 is positive, so it's going to be quadrant 1. Inverse cosine lives in either quadrant 1 or quadrant 2. Positive 1, negative 2, this is negative, so we'll go with 2. So when we're drawing these triangles, we want to draw them in the correct quadrant based on the inverse trig function we're dealing with. Inverse cosine and inverse secant have first or second. The other four have either first and fourth. First positive, fourth negative. For cosine secant, first positive, second negative. So when I'm drawing these two triangles, so inverse sine of 3/5 to begin with, I'm going to draw a first quadrant. I'm going to draw a vector in the first quadrant. And I draw a line straight down to the x-axis, or straight up to the x-axis, whichever side of the x-axis you're on. Always go from the end of the vector directly perpendicular to the x-axis. And the angle itself that we're dealing with is going to be this angle in the corner. And again, just to give it a name, I'm going to call it alpha, the right angle positioned here. The sine of an angle is opposite over hypotenuse, so the opposite measure is 3, the hypotenuse measure is 5. Hypotenuse is always positive. The legs are positive or negative based on direction. I'm going up, so that's positive. I'm going right, so that's positive. And a 3, 4, 5 right triangle is what we expect. So just like that, I've got an angle alpha. So just to highlight this, this angle alpha is inverse sine of 3/5. If I do the same thing for cosine inverse of negative 5/13, I'm in quadrant 2, so I'm going to draw quadrant 2. I'm going to draw a vector out into quadrant 2, like so. I'm going to draw directly to the x-axis perpendicular, so it goes like so. And I'm going to call this angle beta, because it's obviously not the same as alpha. Alright, cosine is adjacent over hypotenuse, so 5 and 13 are the side measures. Again, the hypotenuse is always positive. The adjacent and the opposite are going to be positive or negative based on direction. I'm going left, which is negative, so the minus sign for the negative 5/13 goes on that adjacent side. And the Pythagorean triple happening here is 5, 12, 13. If you get a Pythagorean triple, by all means use it. If you don't know what it is, Pythagorean theorem still works. Notice that side is going up, so it's a positive 12. So the direction that you're going is dependent upon what signs are. Going up is positive, going left is negative. Hypotenuse always positive. Right positive, up positive, hypotenuse always positive. So now, if we take a look, this angle beta is what inverse cosine of negative 5/13 is. This angle alpha is the inverse sine of 3/5. So this problem can then be transformed from what it is into this problem, sine of alpha plus beta. Because that's basically what we're doing here. Alpha is an angle, beta is an angle. I've got a visual representation of what both these angles look like, along with the opposite adjacent hypotenuse for each one of those. I've changed this problem into, instead of sine of inverse sine and cosine, sine of two angles that we have some information about. And it is the exact relationship that number 32 on our trig identity sheet is. Sine of a sum tells me that I'm supposed to do sine of the first, cosine of the second, plus cosine of the first, sine of the second. And if I'm looking for sine, cosine of each of these, sine of alpha is opposite over hypotenuse of alpha. Cosine of beta is adjacent over hypotenuse of beta, which is negative 5/13. Plus cosine of alpha is adjacent over hypotenuse of alpha, which is going to be 4/5. Sine of beta is opposite over hypotenuse of beta, which is 12/13. So again, I'm drawing the triangles. That allows me to identify any trig functions I need to know. I need to know these four specifically. And then it's just a matter of evaluating what I got. So negative 15/65 plus 48/65 combines to make positive 33. 64 should have there. 65, there we go. 33 over 65 is the end result of that. Recognize these for what they are, and again, consider this is an angle, and think about your trig identity sheet. If I saw a problem that says this, cosine of 2 tan negative 1 of, let's say, 3/4. Okay, this is an angle, right? So basically that's just cosine of 2 alpha. Cosine of 2 alpha is number 36. Cosine squared minus sine squared, 1 minus 2 sine squared, 2 cosine squared minus 1, take your pick. Inverse tangent of 3/4, first quadrant, opposite side 3, adjacent side 4, hypotenuse 5, sines 3/5, cosines 4/5. Just like that, I can find the sine and cosine of alpha real easily. I can evaluate it. So this is an angle, cosine of twice an angle, that's a double angle formula. If it says cosine, let's say sine of, let's say, cosine negative 1 of 5/13 over 2. That's just sine of alpha over 2. That makes alpha. Okay, so again, related to these trig identities that we dealt with, adding angles, multiplying angles times 2, doubling them, halving angles, that kind of stuff. And again, your triangle that you create off of this allows you to find any information you need to find about the sine, cosine, tangent, or whatever of that angle that you're dealing with. Apply the proper identity to get the answer.